Hey everyone, welcome back to the channel Code with AKJ. Today is day 30 of solving LeetCode 75 challenge series. So in today's video, we'll be solving the odd even linked list question. So we'll start with the brute force approach and then move on to the optimal solution. So let's get started. So the question says, given the head of a single linked list, group all the nodes with odd indices together followed by the nodes with even indices and return the reordered list. The first node is considered odd and the second node is considered even and so on. Note that the relative order inside both the even and odd groups should remain as it was in the input. So you must solve this problem in O of 1 extra list complexity and O of n time complexity. So here we are given the head of a single linked list. Our task is to group all the nodes at odd indices together, followed by the nodes at even indices, while maintaining the relative order of both groups. So given in example 1, the input linked list given here is 1, 2, 3, 4, 5. Since we need to order the odd indices first and then the second be the even indices. So the odd nodes are 1, 3 and 5 and even index nodes are 2 and 4. So first the odd nodes should be grouped and then the even nodes should be grouped after the odd nodes. So let's get started with our brute force approach. The idea of our brute force approach here is to store all the odd indexed elements in one list and all the even indexed elements in another list. And then we'll merge both the list at the end. So this requires extra space, so it does not meet the O of 1 space constraint, but still it's a brute force approach. So let's quickly dry run with this given example and then we'll move on to our code. So here I've written the example 1, which is 1, 2, 3, 4, 5. So our brute force approach idea here is to store all the odd index elements and the even index elements in two separate lists. We'll merge both lists at the end and we'll return the head pointer. So since it is a one based index, we'll just first write the index of all the nodes, and now we'll create the two vector and we'll store all the odd index elements in one vector and all the even index nodes in another vector. So the odd index nodes are 1, 3 and 5 and even index nodes are 2 and 4. So since we have stored all the nodes in two different lists, now we'll merge these two lists. So the merging of these two lists becomes 1, 3, 5, 2 and 4. So since we have merged this list and now we'll convert this vector of nodes into a linked list. So we'll take a dummy node which would be initially null and we'll start iterating over our list and we'll store all these values and we'll store it in the form of node. So the first node becomes 1, second node becomes 3, third node becomes 5, fourth node becomes 2 and last node becomes 4. So in this way we'll convert our vector into a linked list and finally we'll return the head of our linked list. So this would be our idea of brute force approach. So let's quickly move on to our code and let's submit. So here's the code for our brute force approach. Here the base case here would be that if the input linked list is null or it has a single node, we'll return head pointer. So here I have taken two vectors, that is one is odd vector and one is even vector. I have taken a temp variable which is of type list node which would be pointing to head initially. I have taken the index value which would be initially 1. I have used a while loop until or unless this temp becomes null. We'll check each and every index. If it is an odd index, we'll push that particular node in our odd vector, and if it is even index, then we'll push that node in even vector. And we'll move our temp pointer to the next index and we'll increment our index values. We'll again take the help of this temp node pointer which would be initially pointing to head pointer, and then we'll reset our index to 0. Now we'll use two for loops to iterate over our two list. So first we'll iterate over our odd list since grouping start with odd indices and then followed by the even indices. So start iterating over our odd vector and we'll try to store all the values with the help of our temp node pointer, and we'll move our temp pointer to the next value. So until or unless this vector becomes empty, we'll try to store all those nodes into our temp vector, converting these values from vector to a linked list. And finally, after finishing our odd vector values, we'll move on to our even vector values and we'll store all those values at the end of odd index nodes. And finally, after finishing our linked list from both the nodes, that is from odd vector and even vector, we'll return our head pointer. So this would be our brute force approach solution. So the time complexity here would be O of n since we iterate through the list twice, and space complexity here would be O of n since we use extra space for storing those odd and even nodes. So let's quickly run this code. So okay, so let's submit. As you can see, this gives a successful submission. This approach works but isn't optimal because we use extra space. So let's quickly move on to our optimal approach where we are going to optimize our space complexity. So let's move on to our optimal approach. So the idea of our optimal approach here would be to maintain two pointers, that is odd pointer and even pointer. And we'll also take a pointer which is even head. So we'll traverse over this list and we'll arrange these pointers in place to form separate odd and even nodes. Finally, we'll connect this odd list to our even list. So this would be our idea. So let's quickly dry run with this given example to understand how this optimal approach works. So generally, we'll take three pointers here. One would be odd, which would be pointing to head. Another would be an even pointer, which would be pointing to head next. And again, a pointer that is even head, which would be pointing to even. So we'll start a loop until or unless this even pointer and evens next is not null. So until or unless even is not null and even next is not null. So this would be the case. So until or unless these two case satisfies, we'll run a while loop and we'll perform few in place operations to make two different lists, that is one for odd list and another for even list, and finally after finishing our while loop we'll connect those lists at the end. So let's start with our dry run. So the first step here would be to connect our odd next with even next. So this particular one's pointer would be connecting to the evens next, that is 3. And we'll move this odd pointer to its next value, that is odd pointer moves from 1 to 3. So odd pointer is pointing to this value 3. Now our second step here would be to change the links of this given even pointer. So this step here would be even next pointing to the odd next. So the 2's next would be pointing to the odd next. So 2 would be pointing to 4. And after pointing this, we'll move our pointer to its next index. That is, it moves from here to here. Now again, we'll check whether evens value or even next value is null or not. So they both are not equal to null. So we'll again start with our steps. So here odd next value would be pointing to even's next value. So this pointer would be changed. So 3's next would be connected to 5. And we'll move our odd pointer from 3 to 5. And second step here would be to change the evens link. So evens next would be pointing to the odds next. So at the end it is pointing to null. So this pointer would be changed to, and it starts pointing to null. And we'll move our even pointer from 4 to null. So now again we'll check the condition. So since evens pointer is pointing to null, we'll stop our while iteration. And now since we have created two different lists, one is for odd list and another is for evens list, that is in place. Now we'll try to connect this list. So final step here would be to point our odds next to the even head. That is 5 would be pointing from here to 2. So finally our reordered list would be looking something like this. That is 1 is pointing to 3, 3 is pointing to 5, and 5 is pointing to evens head, that is 2, and then 2 is pointing to 4 and 4 is pointing to null. So this would be our reordered list after modifying the next pointers using this while loop condition. So in this way we have achieved our goal in constant space, that is O of 1 space complexity. So the time complexity of this approach would be O of n as we have iterated over our list, and space complexity of this approach would be O of 1 as we have tried to modify the next pointers. So let's quickly move on to our code and let's quickly submit. So here's the code for our optimal approach. Here the base case would be same. If the input linked list has a single node or the input linked list is null, we'll return the head pointer. We'll take three pointers, that is odd which would be pointing to head, even pointer which would be pointing to head next, and even head which would be pointing to even. So we'll use a while loop until or unless even and even next has some value. We'll perform these two steps, that is we'll change the link of the odd pointer and we'll change the link of the even pointer. And after finishing our while loop, we'll try to connect those two different lists. That is, one is for odd list and one is for even list, and we'll merge those two lists. That is, odd next value would be pointing to even header. And finally, we'll return head pointer. So let's quickly run this code. It's working, so let's submit. As you can see, this approach also gives a successful submission, but here the time complexity would be O of n, as we are doing a single pass through the list, and space complexity is O of 1, as in place or reordering and no extra space is used. So this is the most efficient way to solve this problem while maintaining the O of 1 extra space as been asked in the problem statement as well. So if you're finding this explanation helpful, make sure to subscribe the channel and hit that like button. So let's move on to our time complexity and space complexity analysis. So in our brute force approach, we iterated over our linked list and we've tried to store all the nodes in different lists. And finally, we have merged those lists by again reiterating over our vectors, converting our vector values into a linked list, and finally returning our head pointer. So the time complexity here would be O of n, and space complexity here would be O of n as well, as we have used list to store all those nodes values. And coming to our optimal approach, here we have used pointer manipulation is in single pass, so the time complexity here would be O of n, and space complexity would be constant as we haven't used any extra space. So the space complexity in our optimal approach is O of 1. So that's it for today's video. I hope you found this explanation helpful. Let me know in the comments if you have any doubts or if you want me to cover our specific problems. So don't forget to like, share and subscribe to stay updated with my latest coding solutions. I'll see you in the next video. Thank you.